in this video, we will talk about a more advanced vector operation, which is called dot product. Dot product is a vector operation between two vectors. So you must have a vector dot another vector. Unlike scalar multiplications, we would have a scalar times a vector. Okay, so dot product is an operation between two vectors. Dot product is an operation between two vectors, and these two vectors need to stay live in the same space. Okay, so here on the top we have a vector that only has two components. What does this say? This says this vector is in a two-dimensional space, and same here. So the vector v is also a vector in a two-dimensional space. Then we can say the dot product of vector u and vector v. So we also say u dot v. Okay, so the definition, I'm gonna write DEF. This is how we define what it means by vector u dot vector v. So it's this formula: u1 times v1 plus u2 times v2. Okay, so I basically do a sort of like multiplication component by component, u1 times v1, then plus u2 times v2. Okay, so here you can see on the right hand side, what I get is a number. Let me give an example so that you can see. Suppose on R2 I have a vector, unit vector. So u is a vector. Now it's 1 in the x direction, 0 in the y direction. Okay, and let's say I have another vector. Let's make it longer. So I have vector v is 2, 2. Okay, so two units in the x direction and 2 units in the y direction. So now if I want to look at the dot product of u and v, according to the formula, I would have 1 times 2 plus 0 times 2. Okay. Then I have 2 plus 0, so this is equal to 2. Alright? So now I want you to pay attention that for dot product vector dot a vector, and the result is a scalar, meaning a number. Okay, so remember, a vector is a directed line segment. A scalar is just a number. So you can see when I have a vector dot another vector, I get a scalar, and this format tells me how big or how small the scalar is. Similarly, if I have two vectors living in R3, I have a similar formula for the dot product of these two vectors. And you can guess, I'm gonna have u1 times v1 plus u2 times v2 and so on. So on the right hand side of the multiplication of the first component times the multiplication plus the multiplication of the second component plus the multiplication of the third component. Okay, so example. Suppose I have u equals 1, 2, 3, a vector in R3, and I have vector v equals 4, 5, 6, another vector in R3. Now I do vector u dot vector v. Okay, be careful, I I say dot, I don't say times. I don't say u times v. I will always say u dot v to emphasize I'm doing dot product, because later we're gonna learn more vector operations. Okay, so u dot v. Now according to the formula, 1 times 4 plus 2 times 5, 2 times 5 plus 3 times 6. Okay, so let's write this out. 4 plus 10 plus 18. This gives us 32. So as you can see, we still have this format. A vector dot another vector equals a scalar. So whenever you do a dot product, if the outcome is not a scalar, something's wrong. If the input is not two vectors, then something's wrong. It has to be a vector dot a vector, and the outcome should always be a number. Okay, so there you go. This is how you find the dot product of two vectors. The two vectors need to live in the same space. Okay, so it's the formula for vectors in R2, formulas for vector in R3. They're basically the same thing. Okay, so dot product.